Welcome to the first lesson on the Java if statement that gives you an overview of conditional statements and relational operators, which allow your programs to execute certain blocks of code and bypass others. After completing this lesson, you'll understand why these concepts are essential to writing efficient Android apps. You'll also know how to program these concepts using the correct Java syntax. To motivate the Java if statement, we'll use a simple game feature that conditionally changes the color of a player's avatar based on their location. This game reappears throughout this module to showcase how and when to use Java if statements. By now, you've probably thought about things like, what if I want to set max to 10 sometimes, and sometimes I don't? Or what if I want to print out only the names of players with scores above 90? What you are searching for are conditional statements that determine if some action will be performed or bypassed. And Java has a construct designed just for that. Let's start with a motivating problem. Suppose you are designing a game and you are coding a portion that sets the player's color. If a player moves into the northeast or southwest quadrants, we want to turn the player green to symbolize that they're safe. If they move into the northwest quadrant, the player would turn purple, and if they move to the southeast, red. In each case, they are getting close to one of these monsters. Think about this problem for a minute. Pause the course and try to design a diagram when the location of a player is retrieved. If you'd like, use the symbols like the ones shown on the screen. How did you do? Did you see the problem this way? We see first if the player is in the northeast quadrant. If not, check the southwest. Either of these locations yields a green outcome. Otherwise, continue by checking for the southeast quadrant, and finally, if needed, check for the northwest. But there are some problems with this approach. For example, notice that the setting of green appears twice in our diagram. Also, there's this awkward outcome where we don't quite know what to do. Let's look at another attempt at this problem. Now this diagram seems to have resolved one of our issues. With a more complex test in the first decision, we can decide on the green coloring right away. But the idea of what to do at the last choice still leaves us with a problem. Let's get into the material and see what the Java language has to offer. To handle the types of choices we've just talked about, Java uses the if statement. The simplest form is shown here. The diagram on the right illustrates the idea. If some test is true, the controlled statements, the ones in blue boxes, are executed. Otherwise, they are bypassed. In either case, the statements not controlled by the test are executed. Notice the syntax in sample. If the total is greater than or equal to 10, we would execute the print statement and the reassignment of the variable total. Otherwise, these statements in blue are bypassed. How do we create these tests? We're going to need to learn to write relational expressions. Each relational expression results in a Boolean value of true or false. We often call these Boolean expressions. Here's a table of relational operators that we use in Java, which shows syntax for equals, not equal, less than or greater than, and less than or equal to, greater than or equal to. Here are a few simple examples. Each Boolean expression results in true or false, causing the controlled statements to be executed or bypassed. Let's consider a situation that could lead to a more complex Boolean expression. Suppose we want to test some variable x to see if it is between -10 and 10. This can be thought of as two tests like you see here. But we can do better. Consider these diagrams. On the left, we test for a number greater than -10, which can be many numbers such as -7 or 5 or 17. Then we test to be sure those numbers are also less than 10. But these relational expressions can be combined with an AND operator, shown here in Java as two ampersands. The single AND statement makes the code easier to read and shorter. Completing the diagram helps us to see the results of both outcomes of the relational expression. Here is the code of a compound Boolean expression. Using the and or double ampersand makes this code shorter and still very readable. It better reflects what we are trying to model. There are several logical operators we use in Java. They are the and, or, and not operators. The truth table below, a common tool used in logic classes, shows the outcome for each of the two binary operators and or. Notice if two expressions P and Q are both true, then we evaluate P and Q, the result is also true. P or Q results in true as well. However, when either P or Q is false, the and statement is no longer true, but the or statement is. Finally, when both statements are false, both operators will yield a false Boolean value. The not operator changes the value from true to false or false to true. Armed with these concepts, let's return to our game. Now we know how to form the Boolean expression to evaluate if the position is in the northeast or southwest quadrant. If our location matches either of these quadrants, the expression would be true, and we would color our player green, or safe. Players who fail the test would be considered unsafe, as they are dangerously close to one of two monsters. All that's left is to color the player red or purple. We currently have a test for southeast and one for northwest, but let's take a closer look at the outcomes. A player must always be in one of the four quadrants, and let's just assume location 0, 0 would be considered northeast. When we discover the player is not northeast or southwest, and we then test for southeast, what are the possible outcomes? Either our player is in the southeast quadrant, or they must be in the northwest quadrant. There's no need to test for northwest. Instead, we can simply assume that if they aren't in the southeast quadrant, they should be colored purple.
In our next lesson, we will examine a few other common forms and uses of the if statement. We will also return to our game and begin to put together the code. Now that you've completed this lesson, you should understand why conditional statements and relational operators are essential to writing efficient Android apps. You should also know how to program these concepts using the correct Java syntax. By understanding conditionals, you have added more capability to your expanding knowledge of Java and Android programming.